Yeah, so essentially where we are right now, what you're seeing is kind of a snapshot in time in terms
Hmm.
of one way to resolve this the skin, which is really probably the most complicated part of the project itself. We're in the process of challenging ourselves to think of other ways or methods that we could do that could achieve the right results and be able to meet our budgets and our time constraints
Hmm.
and still maintain, what we set out to do in the beginning. So
Okay. Are you guys under construction right now, or not quite yet?
they are moving dirt and have begun a lot of the initial phases for the overall development there on site. So if you go out there today, you can kind of see that underway.
Okay.
And where we are with everything else is really kind of getting everything ready to go. We're
Hmm.
targeting a 2019 open date. So
Okay.
as you can imagine, it's getting really close.
Sure. Okay. Cool. So let's hop back to the. What are you guys calling this? Are you calling this a roof? Are you calling this the skin? What are you calling it?
Yeah, we've kind of called it the skin,
Okay.
just because it does kind of shoulder around and kind of do a couple of things.
Cool.
So yeah, so the roof problem here that we're looking at. What we wanted to do is we wanted to, rather than design something and come back late in the process, late in DD or even CDs, and start to work with a fabricator at that point to kind of resolve all the challenges and to maintain what our architects like to call design intent. We decided makes a lot more sense for the way we work to really kind of deliver that design intent through an understanding of the fabrication process. And so we worked really early to start to understand available materials, available processes, and different equipment on the shop floor so that we could really kind of build some intelligence into the system based on what we were able to accomplish. And so
Okay.
what we're seeing here with these perforation constraints, this is kind of funny when you look at it, but essentially we're constrained more by time than anything else. It was determined pretty early on that we can go two routes when you're rationalizing a surface like this, and one of them is to create a modular piece. And so we could say we're going to have one triangular element that will comprise this entire skin system, and that's certainly a way to do it. And quite honestly, in traditional kind of construction methods, that made a lot of sense for many years. But now, with the ability for mass customization and with new fabrication techniques, the way that we were going to cut the triangles and to punch the perforations,
Hmm.
um, really it didn't save us a lot of time to make them all the same size. And so what we're looking at here is how can we meet the time limitations. And so we determined that based on the available machinery and techniques that we had in the open date not moving, we could use up to 8 hole sizes to achieve this perforation pattern, and we needed to keep these perforations under 52 million. At that point, it was going to be really hard to kind of meet our schedule. And then the material constraint, based on the gauge of the material and the type of material, we needed to maintain greater than a half inch of spacing between the holes for the structural integrity.
I like that. Only 52 million holes. How is that magic number come out? Is it you find out that it takes so much time to punch a hole, and you have a certain time in your schedule or something?
Exactly. It's about as simple as that, as pulling out the calculator and kind of backing the hours in the years and
Yeah.
understanding if we have X amount of seconds per hole, um,
Man,
we can extrapolate that and understand how many we can punch. Yeah.
that's awesome. Okay, cool.
Okay, so the detail that we talked about, so these perforations that are creating this overall visual image and allowing for this kind of permeable facade, those are going to be punched. And so what we're looking at is kind of the detail of the coined die punch. So there'll be various sizes, but they will be punched at the same machine station where the triangle is actually cut around the perimeter.